Okay, everybody, let's look up here. We're on the last part of lesson 56, okay? Systems of inequalities. When we're dealing with systems of inequalities, they're not equal to each other. We're going to be shading on one part of this. So the first thing we're going to do is plot this line. We're going to pretend like this is an equal sign for a minute. We're going to say that line is in slope-intercept form. So its y-intercept is -4. 1, 2, 3, 4, right? Its slope is up 1 over 2, up 1 over 2. So we're going to go up 1 over 2, up 1 over 2, and there is the line. Now, I'm going to make it a solid line because this is greater than or equal to, right? So it's not going to be dotted. Whoops, that doesn't look like a line anymore. It's going to be solid, okay? And y is greater than is going to be up above, but just to check, we can always put in a test point 0, 0. We can plug in 0 here and 0 there. Is 0 greater than -4? Yes. So we should shade towards that point that solves, okay? Then we're going to come in here and do this one, okay? And this one is a what? Just looking at it, this is a parabola. Remember that all of your functions are ruled by their highest degree term. Since the highest degree term is an x squared, you know this is a parabola. You also know it's facing which way? Downward, because it's got a negative on the x squared term. So we talked about completing the square and how to figure out what the vertex form of that parabola is. So let's do it. We start by pulling out the negative. And then we're going to put the x squared. And instead of the 4x, we're going to put a -4x, because when I distribute that through, my sign will be correct. And then I'm going to tuck my -1 out there. We're completing the square. Then I'm going to cut this one in half, -2. I'm going to square it, 4. But I really just added a what? Negative. I really just added a -4. Therefore, I will compensate by adding a +4 outside. Okay, so this one becomes negative x minus 2 quantity squared plus 3. Y greater than or equal to. So where do I plot that parabola? It's going down. Its vertex is what? 2, 3, right? The vertex is 2, 3. So I'm going to come over here. 1, 2, 1, 2, 3, right? And my parabola is going downward. So I will be having, and it is a normally shaped parabola, which means it's going to go over 1, down 1, over 1, down 1, over 2, down 4, right? 1, and that's at 3. So it's going to come down to there on both sides at 2. Okay, so here we got general shape of that parabola. Now I'm shading y is greater than, so that should be above the parabola, but let's check a test point. Let's just plug in, since I have not graded this real carefully. I think this 0 is not in there. So let's plug in the 0 to see if it works or not work. Okay, if I plug in the 0 right here, that becomes a 0, that becomes a 0, and I have 0 is greater than a -1. Is that true? Yes, right? 0 is greater than -1. So my 0, 0 is outside my parabola, which is what I thought to start with. So I'm going to shade in that area, okay? Now, if I am, now it depends. Am I shading a this one and this one, or a this one or this one? Okay, this is where our logic comes in. If I'm shading this one and this one, if there's an and in between, I will take the intersection of those two graphs, okay? I will take what? Is all above this line, was what we had originally, but now I would take this intersection. I would take this part that's going in here, above the parabola and above the line would be my and solution. If you saw an or in between there, that means any part that solves one or the other, okay? And it would include this part inside the parabola as well, because the part inside the parabola solves one of the function. So you would do everything that's shaded once if you were doing an or. If you're doing an or, it's everything that is shaded once. If you're doing an and, it's everything that's shaded twice is the solution. Okay, so you need to know the difference between those. Questions on that? Anybody? Questions on that one? Okay, we're going to go over here and do the last one over here for this section. Okay, so we've got, hopefully it's seeing my screen, we've got a circle. This is a circle of radius what? X squared plus y squared is radius squared. This is a circle of radius 4. So 1, 2, 3, 4, circle of radius 4. Now, if I've got this less than or equal to the radius, where do you think that's going to be shaded? This is talking about all the points that are less than or equal to the radius inside the circle, right? But let's check. Let's plug in a 0, 0, which is inside the circle. A circle can only be shaded inside or outside, right? So I'm going to plug it in. 0 and 0 is 0 less than 16. Yes. So the inside of the circle gets shaded on this one. Yes, David?
Can you go to the bathroom?
Very quickly. Then, how would I graph this line? Y equals to X. That one we should be able to do in our heads, right? Because that's our identity line. Whatever point we put in comes out, right? So we plotted here. We got 1, 1, 2, 2, 3, 3. And that's our identity line. And it's going to go straight through the 0, 0. Okay. Now, I'm shading this, though. Y is above the X. So I'm going to be shading this direction. And in order to check that I shaded the right way, I can't use 0, 0. Because I just went through 0, 0. Okay, so I would pick a point like 0, 1 to check it. If I checked a 0, oh, excuse me, wrong line. If I checked a 0 and a 1, would it be true? 1 is greater than 0. Therefore, I am shading in the correct direction. Okay, again, if we're looking at an and situation, making both equations true, we have to take the intersection of these two groups in the circle above the line. And so this would be the solution area right here, the part that solves both of those. Any questions on inequalities that are nonlinear? Okay. I wish this thing would time out.